Missing length. So we would always start with our missing length. Oh. All right, so we start with the unknown letter, x. What will I divide x by?
8.
8. And what would I say that that's equal to?
3/5.
Oh, you lot are O for awesome. And so x equals
3/5 times 8.
5 multiplied by 8.
Which equals a number, yay!
Secretly over 1, which is 24 over 5, which is 5 and, oh, no, so not 5, 4 and 4/5.
Yay, we understand.
Okay, so next bad boy, x over what?
5
Equals.
7 over 4.
Oh, you lot are just so awesome.
7 over
7 over 4 multiplied by 5 over 1,
35 over
which is 35 over 4, which is 8 and 3/4. Yes, me and my aim. Okay? It's pretty straightforward, isn't it?
Yeah,
Nice.
understand.
Okay, so the diagram shows 2-meter wide path around the 12 by 8 swimming pool. Are the two rectangles similar? Justify your answer. All right, so oh my gosh. So first things first, our small rectangle has the dimensions 12 by 8. Okay. What would be the dimensions of the big rectangle? No, we don't need an x. What would the dimensions be?
14.
14.
Think about it. This is 12 and the path is 2.
Oh, 12 by 16 by 10. 12 by 10.
Both sides, Brianna.
12 by 16. 12 by something.
So this is 16, yes, and this bad boy is 12. Lots of people were shouting at me. Okay, are we all good? Brianna, yes, because they're both sides is 2 meters.
12.
So it's 8 plus 2 plus 2. And then this is 12 plus 2 plus 2.
Thingy is only right there.
No, Angel, this is saying it's a 2-meter wide path, but it goes all the way round, look. You hear me, sister?
Yeah.
No, Elena says she's confused. What's up? So this is 12. This is 8. It's a 2-meter path all the way round. So this must be 16 and this would be 12. Are you with me? So we're trying to decide, are these two rectangles similar? So what did we say? If they're similar, the corresponding lengths would, when divided by each other, would give you the same value. So if they are similar, 16 divided by 12 would be equal to what? Careful.
12 divided by 8.
12 divided by 8. Remember, we've got to stay the same rectangle. Is it confusing because there's two 12s?
Nope.
We're good? There are two 12s. Is that what's confusing people? So this 12 here has come from here. And this 12 here has come from here. So is 16 over 12 the same as 12 over 8? Okay, well this is what you would have to do. So where some people are like, oh no. So we would simplify this. What's 16 over 12? How does that simplify? What number goes into 16 and 12?
3.
4 goes into it, so it becomes 4 over 3. And what number goes into 12 and 8?
4.
Wouldn't it be like in the other one?
3 and 2.
1 second. Do this. To be a similar shape,
Yeah.
corresponding sides when divided by each other would be the same value. So this long length divided by this long length would have to be equal to this short length divided by this short length. Does that make sense now?
Yeah.
So yes, 12 and 8, the dimensions would be the other way around, but when we're doing this calculation, the division is that way around. Yeah? Now, can we all see that 16 over 12 is not equal to 12 over 8? Yes, because we've got 4 over 3 and 3 over 2, so they are not similar.
But why? Because you're adding the same thing to them.
No, but you're not multiplying. So similar shapes tend to only occur when you're multiplying things by the same number. Because it's like saying, if you've got 2/3, if you added 1 to both of these, you wouldn't have 3/4, even though you've added 1 to both of them. It's not going to give you the same fraction. Yes? No?
Okay. It's just like why when you like add, because like sure, like say you have like two, like you have a square and like you add.
But if you're adding a square, then it's going to be still a square. But because it's a rectangle, it's not. It's going to be different. You're going to have to multiply things. It's got to be in proportion. It's got to be in the same ratio as it was before
Okay.
to be a
but
similar
you
shape.
add like 4 to both the width and the height. Is that not? That's what we're doing here. It doesn't work.
No, it doesn't matter what numbers you add. It's not. It's on some occasions it may work, but majority of the time it wouldn't. It depends which numbers you started off
The
with.
ratio changes even though you're adding the same thing.
Yeah.
Okay.
Yeah. So ratios will only ever stay the same if you're multiplying. So ratios have to be multiplied.
Yeah, we understand.
Okay? Show that the following figures possess similar triangles. Oh gosh, these are quite a lot. Okay, let me